Traveling in a straight line is not the fastest route, not always. Try moving in a cycloid and subscribe now to the History of Math on the YouTube channel What Makes It Tick. Sometimes mathematics can help to correct our intuition. For example, I have a question for you. How many people do you need in a room to have a chance greater than 50% to have two people born on the same day? Maybe you think like 100 or 50. No, 23 people are enough. For example, if you take a soccer game, twice 11 players plus the referee, that makes 23. There is a probability greater than 50% that two people on the playground are born the same day. And mathematics can help a lot to deal with our intuition. Another good example, completely different. Let's take two dots, A and B, and you want a ball go from A to B as fast as possible. Which path would you organize for the ball? The first intuition could be a straight line. And of course it goes fast, but at the beginning it's a bit slow. So you can have another idea, something like that, with a very strong start because of the fall, and then you lose some momentum in the curve. So this is a simple question, a very tough question. Even Galileo was convinced that the fastest way for a ball to roll from A to B was a quarter of a circle. In fact, this is not the answer. The real answer is what we call a cycloid. It's a very strange curve here, and the best way to draw and to understand what's a cycloid, if you take a table, for example, and a coin, and you let the coin roll on the table. Now take a fixed point on the coin, on the circumference, and you follow the path of this fixed point. This curve is a cycloid. And the cycloid is an example among many others of a fantastic formula, a fantastic curve. And this curve, the cycloid, has many uses, very strange properties. For example, in clocks, before electricity of course, people had to use pendulum to measure time. And you know what? If you take a pendulum and you jam the pendulum between two cycloids, like this here, the amplitude has no impact. It will always exactly the same time. So it's an ideal tool to manufacture clocks. And on the top of it, you know what? The curve, the path followed by the pendulum here is just another cycloid. That's magic. Leonhard Euler's obsession with the bridges in his home city led to the birth of topology. Find out more in the next episode of our series, The History of Math. Subscribe now.